come closer. Oh, okay, that's nice. Okay, hi everyone. Do you know gas turbine? Yeah, gas turbine that we learned in thermodynamics too. Oh, you don't know? Oh, I also don't know. How about we ask a person that know what is gas turbine? Gas turbine. Okay, that's
Hey Zamir.
hey, Khalid.
Yes.
Do you know about gas turbine?
Maybe a bit about gas turbine.
Oh, can you explain to me and to the audience?
Okay, of course.
Okay.
Let me explain about gas turbine. Wow. Okay, now I will tell about application. Gas turbine. Gas turbine is related to Brayton cycle. Brayton cycle is an ideal cycle for gas turbine engine, also known as Joule cycle. The inventor of this Brayton cycle is George Bailey Brayton, who birthed on 3rd October 1830. He was an American mechanical engineer. He was the first to introduce the constant pressure engine that is the basis for the gas turbine, now called as Brayton cycle. In 1872, he designed a constant pressure internal combustion engine, also known as Brayton's Brady motor. In 1874, he filed a patent for liquid fuel injection. In 1881, John Philip Holland used a Brayton engine to power the world's first successful self-propelled submarine, the Finian Dream. In 1890, Brayton designed a 4-stroke engine with an air blast fuel injection system, also known as diesel engine. Application. There are two major application areas of gas turbine. The first one is aircraft propulsion system. In this system, generally gas turbine is a main component in engine to draw more pressurized air into combustor section. The second one is electric power system. The gas turbine is needed to produce electricity.
Yes, now you know what the application of gas turbine. And now I would like to explain to you how it works, what the gas turbine function. Okay, we go to the gas turbine. So how a gas turbine works? So actually it will produce with air. Actually air is a working substance that is used in a gas turbine. And also, as you can see here, we are talking about gas turbine. The air will be combined with a natural gas or liquid fuel in order to spin the generator in the turbine, and at the same time it will be supplied to the all houses, factories and others. And you know that in the gas turbine, and also it has a cool air gas turbine, then the air will be compressed and squeezed in the compressor section. As the air will be compressed very high, so they will be hotter. The temperature will be increased and also the pressure will be increased. And besides, the fuel will be injected into the combustor to produce hot compressed air, and at the same time it will be burned, and it uses the chemical energy. And the horsepower in order to produce or to functioning the gas turbine also increase, and it usually used in the aeroplane. And as it goes, the speed is also increased to 3000 rpm, which is revolution per minute. And actually the chemical energy will be converted into mechanical energy. So the drive shaft in the gas turbine will be connected with the generator in order to produce and function it well. And we have a magnet and a coil which is functioning to produce the magnetic field in order to produce the electricity, and also produce electron flow. And mechanical energy at the same time will be converted into electrical energy. This is all for the gas turbine.
Okay, now let's go through about the improvement in gas turbine. Yeah.
For the improvement for gas turbine, Many things can be done to keep a turbine operating at a peak efficiency. Inlet conditioning, which is reducing the inlet air temperature, is a very common method for improving gas turbine output. There are three well-known methods for achieving this output improvement, which is fogging, evaporative cooling, inlet chilling. For fogging involves injecting atomized water into the inlet air stream downstream of the inlet filters. The system carefully controls the amount of water injected to ensure no large droplets of water are ingested into the compressor. For the evaporative cooling equipment is installed in the inlet ducting after the filtration system. The system consists of a media bank in the air stream, which is continually wetted by one or more water pumps. As the incoming air passes through the media, it absorbs some of the moisture and at the same time loses heat, resulting in cooler, denser air. This dense air then enters the compressor cooler. Denser air allows the turbine to produce more output power with improved turbine efficiency. For inlet chilling the inlet air stream is an effective way to increase the air density and thus improve turbine output. The chiller is typically a large mechanical refrigeration unit, which is adjusted to provide a controlled inlet air temperature to the compressor. No matter what the ambient air temperatures are, the chillers ensure that the compressor inlet temperature will not exceed a specific target temperature.
Hi, just now you have been taught about the improvement about gas turbine. So now I would like to explain to you the latest technology of gas turbine.
Hi, so I will explain to you the latest technology innovation of gas turbine that we use nowadays. So I present to you the gas turbine SGT 800. Gas turbine is the beating heart of every combined cycle of power plant. Piece of machining that mix air and fuels and turn it into the power that light up life and drive growth around the world. SGT 800 is the latest technology that pushing the boundary of possible. It can deliver unmatched level of performance with the world's most innovative advanced material, cooling, aerodynamic, combustion, and digital capability. With new design of blade and increase the efficiency. Simple robust design of high reliability and easy maintaining is the characteristic of this new latest gas turbine. A high efficient turbine design offering optimal performance and lifetime. Excellent fuel flexibility allow for high contact of which is more than 325 gas turbine has been sold. Which is more than 325 gas turbine has been sold worldwide. And more than 5 million equivalent operating hour for flex experience and more than 99.5% overall fleet reliability.
That is the explanation about gas turbine. Do you understand it?
Yo, okay, I finally understand what this gas turbine is about. So, how about you guys? Do you understand it? Okay, so if you understand it, you can subscribe and click the thumbs up below.